Good evening, everybody, and welcome to Lyft, and welcome to this Payments Meetup and Tech Talk. We're all super excited to have all of you here. It's amazing to see so many people here at Lyft, and also amazing to see so many payments nerds all under one roof. I mean, who else would take their evening off and at 6 in the evening and come for a payments talk? But it's a happy family of payments nerds here. Super excited to have all of you. My name is Anand. I'm a product lead here on the payments team, and we are super excited to have all of you here. At Lyft, we care deeply about our community, and this is one of our core values. When we think about how can Lyft add value to our cities, we think about how can Lyft add value to our driver community. In the same vein, this event is really to see how we can learn from each other in the payments community here in the Bay Area. We have an amazing set of speakers today lined up. We have people from the Lyft engineering team. We also have people from Netflix and Airbnb. A huge round of applause for our colleagues from Netflix and Airbnb who are here. Our goal through this tech talk is really to see how we can share and learn from each other in the payments and billing space. How can we build and scale payments in the online marketplace ecosystem? So without much ado, I'll hand over to Ashwin, who will kick this off.
Okay, thank you. I love this crowd. Look at us. Thank you all for coming. This is a phenomenal turnout, and really, I love seeing the cross section of Silicon Valley and industry, and the common theme of payments that goes across all of us. So, what it tells me is, as a payments group, we should probably have more of these events where we have the opportunity to meet with each other. And I've had some amazing conversations with people already, and it's we've just gotten started. So I'm looking forward to the rest of the evening, and hopefully, as Anand mentioned, our objective is to share Lyft overall. As you may have realized, we are very socially driven, and we are a company who feels that we need to benefit everybody as much as possible, be it the community, which could be our driver community, broader society, our employees, but also our partners in the extended ecosystem. And so we believe that information should not be held within a constrained environment, and it should be shared with everyone so that everybody benefits and we make further progress based on that information. I'll start. Hopefully, I won't take too much time because I let the true payments and other speakers to give you details about what we do at Lyft, and looking forward to Netflix and Airbnb sharing their perspectives as well. But I wanted to start with how payments plays a role in this transformation of transportation. And at Lyft, we've done a little disservice to some of the other areas. Payments is a much broader term, and I'll talk about that. But all of you know about Lyft, and hopefully all of you took a Lyft here. If not, take a Lyft back. But what have we been doing lately? And just wanted to highlight a few key things that has been happening in our world. As you know, we are primarily in the US. We've expanded into Canada and continuing to expand there. We've been very focused in North America, and we'll continue to be so for some more time. We've also made a big push into autonomous. And there's been a lot of news and media about autonomous. Unfortunately, there have been some issues with autonomous as well. However, we strongly still believe that autonomous is a key goal for us in the future, and autonomous vehicles will become part of everyday life. We have hit a milestone that I don't know if many of you know. It's a small number, but we completed 5,000 commercial rides on autonomous vehicles. 5,000 rides is small, but these are passengers who requested a ride, and an autonomous vehicle showed up, and they got into it, and they completed the ride. So it's a small step, but a significant step for us. And we work with multiple partners to make this happen. This is not something that only Lyft can accomplish. And here are some of our partners with whom we collaborate. And then, as you may have heard, now there's a lot of buzz around bikes and scooters. And we've recently launched in Denver with bikes and scooters. And we will continue to grow and expand in that area. This also has a broader objective, because we strongly believe that an individual's transportation needs are not merely restricted to a car. A person, when they want to go somewhere, could choose multiple modes of transportation. And we started with bikes and scooters because we were solving a problem in an urban environment where there's a lot of congestion, and this could help relieve some of those travel constraints. But recently, we've also started surfacing transit information in our app. And if some of you have taken a Lyft ride recently, you would have seen transit information show up. So we are definitely focused on solving for the transportation problem. And we want to make sure that whenever somebody wants to go somewhere, they choose Lyft for their transportation need. And that could be a combination of multiple modes of transportation. And that's really our ultimate goal in terms of where we want to be. Lastly, from a payments, I'll just throw in a payments piece. I'm biased. We just launched a full expansion of our All Access program. This was the subscription service that we had been testing out. We tried it out in a few markets with a restricted number of people who applied for that. But now we're going to roll it out to everybody. And hopefully, this is, again, another step for us where we feel that we can replace car ownership. And if you think about car ownership, right now, all of you own a car, several cars. You pay a lease, or you pay for the cost of the car. And what we're hoping is, through this subscription service, you'll get a certain number of rides that you can then use during the course of the month. And that will eliminate the need, maybe immediately, a second car. But over time, no need to have a car. And I would suggest that you think about the cost of car ownership, because it's not just the lease payment, right? There's maintenance. There's a lot of other things related to it, gas and so on. So if you actually calculate the cost of car ownership, it becomes significantly high. None of us do, including me, but that's the reality. And that's what we're hoping to address as we continue to expand our capabilities. I also mentioned that we're very driven by what we do and how we help the community. And I'll give you just a few examples of some of the things that we've done. And as you can see, for our driver community, we were the first to introduce tips, and we've exceeded $500 million in tips to our drivers. We also invested in the community in terms of helping girls who code. And from an environmental perspective, what we've done is all Lyft rides are carbon neutral now. All Lyft rides. Nobody else has this. And we're proud of this, because we are helping the environment ultimately. And our overall goal as a company, through ride sharing and so on, is to have an environmental impact, because you reduce the number of cars on the road, you reduce the impact to the environment. There are multiple other things, but I just wanted to throw a few things out. And lastly, we've committed $100 million to help our driver community. And there's been a lot of back and forth in terms of drivers and what ride-sharing companies are doing for them. And we made a strong statement to say, we're behind our drivers and we're going to help them. So that's just a few things as to what we've been doing. So I'll now get into payments. So what is payments at Lyft? So payments at Lyft is actually a combination of multiple areas. Identity is one of them. I hope you met some of our identity team members here. This, we manage the access, the credentials, and the validation of those credentials, and the use of the Lyft platform and services. The next piece is fraud. We protect the Lyft platform from the Lyft services being used fraudulently. And this has a lot of payment-related aspects to it in terms of authorizations, chargebacks, et cetera. And then obviously the big thing is pay, where we are providing the transaction processing and all the related elements for somebody to pay for a ride, as well as for drivers to receive the payout once the ride is completed. And lastly, it also includes financial infrastructure, and this is the latter part of it where we are able to report and reconcile those transactions in an accurate manner and give those numbers both for our finance team as well as for our investors. So, we use payments loosely, but it covers 4 critical areas here at Lyft. All those team members are represented here. Please feel free to reach out to them, talk to them about it. You're going to be hearing about a couple of these areas in more detail. So I mentioned that we play a critical role in terms of how the Lyft service works, and I'll give you a quick idea of how that happens. So just to give you obviously there's a passenger and a driver. We are a marketplace. The first step is they're setting up their account. You download the app, you put your credentials in. It varies in terms of the information that we ask for a driver versus a passenger. But here's where the identity team starts getting involved in terms of what are those credentials, how do we validate it. We have some of our partners whom we use for those validation as well. And then the next step is, on the passenger side, it's requesting the ride, and there's a payment authorization that's happening. So this is all happening at the time that you open the app and you put your destination in. All of this starts occurring behind the scenes. On the driver side, obviously there's a driver validation, and then they accept the ride. Once the ride is accepted, you go through the ride experience, and then there is a post-ride experience, which includes rate, tip, and pay. And on the driver side, there's a payout. So here, on the first step, there's identity. Fraud comes in at that point in time in terms of making sure that they're doing all the appropriate checks. Then the payment pieces start coming in, both in terms of pre-ride as well as post-ride. And then after this is where the financial infrastructure piece comes in, so that we're able to now make sure that the right amount, for the right transaction, all of those validations happen. So that's kind of how a very simplistic way of depicting how it works. And before I hand it over, I wanted to stress on one thing. We always stress on and try our best to deliver delight. And I'll give you a few examples of how we do that. So the upfront fare piece was something that we felt would make the customer experience better. The rate and pay and the tipping was something that we introduced first and ensured that Lyft itself, the Lyft ride, which is a social experience, and as a result of having a great experience, you reward the driver in the form of a tip. And then the express pay option, which was also, we were the first to market to introduce this, where drivers get paid out in real time. So we've been consistently leading the industry in terms of setting those trends and in fact, these have become now the standard across marketplaces and the gig economy. But we're also doing a lot of other things. And we are, the fraud team, again, you'll hear from Mike, they do a lot of sophisticated capabilities for ride sharing. We're evolving identity, which is which is very simple at this point in time, but it gets really complex as you start thinking about multiple usage scenarios. And then, even simple things like tax. We have to manage tax-related reporting for our drivers, and how do you drive innovations in those areas? And that's what I really get excited about is these mundane things, these so boring things. There's so much to be done. And it's super cool. And a lot of the team is here who does this, and they do it really, really well. So we pride ourselves in introducing new capabilities that then become the standard for the rest of the industry. So I'll stop there, and I'll let others get into more details. It matters how you get there, and we really believe that. We are a company, as I mentioned, who have strong values, and we want to do the right thing. And hopefully you get a sense of that today, and also have fun. There's wine and beer. I think the pizza is out. Sorry, guys, who came late. But all of you need learn, have fun. That's the goal today. Thank you all for being here.
Thanks, Ashwin. Just give us 1 second. We just need to stream this. I think we're not sharing the screens here. Okay. Cool. Up next, we have Jun from our Lyft Pay engineering team. She's going to talk about reliability and why that's really important in a marketplace ecosystem like ours. She's specifically going to talk about payouts, which is a very integral part of the Lyft payment system. This is paying out our drivers. The number one reason they're driving on our platform is for the money, and it's really important for us to ensure that we pay them out on time and accurately. So Jun, I'll hand it over to you.
Hi, I'm June. I'm an engineer here in the payments infrastructure team. So my team built most of the payment processing systems here at Lyft. So today I'll be talking about how we build a reliable payout system. So to start off, I'll give an introduction to our stack and how it fits into our overall Lyft infrastructure. And then I'll also give a brief overview on what is payouts. And then why is reliable payouts important for us? What are some of the challenges we face? And finally, some of the methods and techniques we use to build a reliable payout system. So as Ashwin mentioned earlier, Lyft is a marketplace that connects drivers and passengers together. So passengers needs to go from one location to another location, and driver provides this service. So where pay comes in this whole overall marketplace is that Lyft has to be able to collect payments from passengers so that we can pay this amount to our drivers. So this is our pay stack. So our topmost level is our client layer. So we have our iOS and Android app. So if you have a Lyft app on your phone, if you add a new credit card, or after you take a ride and at the end you have to pay, you're interacting with our payment system here. We also have some web and internal tooling components. The next one is our API layer. So this is a very simple, lightweight REST front end that acts as a bridge between our clients and our internal systems. The next one is our billing layer. So this consists of our invoicing system. So our invoicing system calculates how much driver needs to get received for a ride and how much a passenger needs to be charged for a ride. So it has to take into consideration stuff like, oh, did this route pass through a toll, or do we have to charge a sales tax? Very complicated stuff. The other component of our billing layer is payment orchestration. So it makes decisions such as what credit card we need to charge a passenger and stuff like that. So the next one is our payment processing layer. So this consists of our gateway. So Lyft doesn't integrate into the banking network directly. So we go through our third-party acquirers and processors. So our gateway will talk to our different third-party acquirers and processors to actually handle the payment processing. So we also have our transaction management system. So as a lot of us here might know, payment has a very complex life cycle. So our transaction management system will manage the life cycle of our payment transactions. The last one is our payment method system. So this is our system that supports different payment methods. So for example, for passengers, we support various types of credit cards, and then also different type of payment methods such as PayPal and like stuff like Apple Pay and different mobile wallets. So this is all handled by our payment method system. So the last layer is our analytics system. So this consists of our data warehouse, and we have a very rich reporting and analytic pipeline built on top of it. Suchi from the financial infra team will talk more about this afterwards. So this is the pay stack. And then next I'll talk about what are payouts. So whenever a driver drops off a passenger, a call will be made to our ride service here at Lyft to indicate that the driver has dropped off a passenger. Our ride service will call our invoice service to make calculation on how much the driver should receive for that ride. So after that calculation is made, our invoice service will send the amount to our transaction management service, which will then write it to our database. So as the driver drops off more and more passenger, the driver earnings will accumulate and aggregate in our database. So more and more earnings. And then afterwards, after the driver finish driving, and if they want to get paid out, they can go to their driver app and click a button to get paid out. So what happens behind the scene is that once they click the button, it will call our transaction management service. Our service will then query the database to figure out what is the amount that the driver has not received yet. Then it will get that amount and then call our gateway system with the account that the driver wants to get paid out to. And from there, we will call our third-party processor, and that's how the driver gets paid out. So, yeah. So we offer two types of payouts here at Lyft. So the flow that I mentioned just now, that's what we call express payout. It's, as you might notice, it was initiated by the driver, so it was on demand. So it's a very popular feature for us here because it's sent via the card network. It's much faster and also comes in real time. So as Ashwin just now also mentioned, that we were the first in the industry to launch this feature in marketplace type business. So we also support another type of payout, what we call weekly payouts. So this is very similar to the direct deposit system that a lot of us might be familiar. So what we have is we will have a scheduler to run every week to find how much we have to pay out our driver after the end of their weekly pay cycle. It's sent via the ACH network. So if you're familiar with ACH, you might know that it's kind of slow and it's not real time. We'll go into more challenges. There's some of the challenges we face with ACH later. So now that you know a lot about payouts, why is reliable payouts important? So payouts need to be accurate. So a lot of us probably have experience getting a paycheck. And then if your paycheck somehow comes in the wrong amount, I'm pretty sure you're going to be really unhappy, right? So our driver expects the same. I mean, if we pay them down less than what they expect, they're obviously going to be unhappy and will stop driving for us, which is loss for us. So on the flip side, Lyft also expects us to pay accurately, because if we pay the driver more than we need to, then Lyft is going to take a financial loss, right? So accuracy is really important to us. So payout systems also needs to be reliable. To use an analogy, most of us probably have experience taking money out of an ATM. When we go to an ATM, we expect that we can withdraw our money. If it's not available, I mean, we're going to be pretty unhappy. So same, the driver needs to expect a reliable system to get paid out. If somehow our system is always down, they won't be able to withdraw their money to get their money into their bank account, and drivers will be unhappy. So payout systems also needs to be timely. So most of us probably have experience cashing a check. We all have experience on when a when a check settles. So same for our drivers. Our drivers expect the money to come in and they be able to spend their money at a certain time. It shouldn't be a variable time. Sometimes it will settle in 1 day, sometimes it settle 1 week. So latency is really important for us. So, I mean, this seems pretty simple. Like a lot of if you talk to any distributed system, like system correctness, system reliability, and system latency is all very important features. But what makes makes it difficult for payout is that payout system is really complex. So we're going to go over some of the challenges that we face in when doing ACH. So when Lyft wants to initiate ACH payout, we will call our processor. And our processor returns success, but that's not the end of it. So what happens behind the scene is that ACH works in a batch method. So our processor actually accumulates all the different instructions and batch it and send it to a clearinghouse. A clearinghouse is basically just an intermediary between different financial institutions for money movement. So all this instruction will be sent to the clearinghouse, and the clearinghouse will process it, and the next day it will be sent to the different banks. So if everything works well, that's the end of it, everyone's happy. Unfortunately, there's always errors. And one of the main challenges we face with errors is that there's no strict time limit on when an error is received. It really depends on the bank. So if there's an issue with the ACH transfer, some banks might return back to our system in 1 or 2 days. Some bank might take out a week. But then to drivers is that there was an error paying them out. So yeah, we're trying to build a reliable system on top of a very difficult system. So now that we talk a lot about that, we'll talk about some of our methods and techniques in building a reliable payout system. So for accuracy, one of the things that we do is that we have a verification system to verify that our previous calculations is correct, which is paired with some sort of online monitoring system. We'll go more deeply into that. For reliability, one of the things that we do is to improve our redundancy by integrating with more acquirers and processors. And then as we have more redundancy, that allows us to do more complicated stuff like circuit breaking, where if a processor is having issue, we can shed load to that processor and route it to a different processor. So obviously, to do something like that requires us to have really good monitoring so that we can very quickly identify if a processor is having issues so that we can start routing more traffic to a different processor. So the last one on timeliness, we have very good end-to-end monitoring on each stage of our pipeline to see what is our latency, which we use via events that we will talk more about. So accuracy. So as was previously mentioned, that multiple servers are involved in calculating how much a driver should receive for each ride. For example, we have a toll service, we have services for various fees, and services for taxes. So all the services will talk to different databases, which all get replicated to our data warehouse at the end of each day. So what we have is a verification job to make the same calculation, to make the calculations in different method using the same data to verify that the calculations in our online system was correct. So this works well for the most part. But however, there is one big downside is that it runs at a lag. Since we run it daily, obviously if there's an issue in our upstream system, we will only find out the next day where a lot of mistakes have accumulated. So what we do is that we have a online system to do outlier detection. So this will continuously monitor. For example, if we have a certain number of rides, we might expect a certain number of tolls being collected. If we see that drop, maybe there was an issue with our tolling service. So then the outlier detection system will be able to detect this and then alarm and page our engineers to look into it. So how do we guarantee that each payout is payout to our drivers? So every time there's a new earnings that we have for a driver, what we do is that our service will schedule a callback using our distributed timer service. So as I previously mentioned, we support express payout and weekly payout. So if a user does not initiate payout by themselves, they will automatically get paid out in the next week. So we know that if a driver has earnings, the latest we'll pay them out is the following week. So what we do is that we can schedule a callback for 1 week to check, has we successfully paid out that driver? If after 1 week, the driver still has not been paid out, that means there is an issue in our system. So that's how we catch if there is issue even for individual drivers. So now I'll talk about how we monitor our latency. So all the different pay-related service is going to emit events, and then all these events will be sent to the event stream in our analytics pipeline. And then there will be workers that ingest all these events, and then it will transform and then sends all, and then talk to our monitoring system. So this allows us to build dashboards to allow us to monitor end-to-end latency of our whole pipeline and each stage. And then it also allows us to build alarms on it so that if any latency spikes, then we will get notified it. So this is really good to give us a very high level and aggregated view. However, we do a large volume of payouts. If even a small percentage of our payouts is late, that means we have unhappy drivers. So to catch all these edge cases, what we do is that we have individual callbacks to basically monitor to make sure we're within our SLA. So whenever a payout is initiated, our pay system will schedule to make a callback to our distributed timer service and then our distributed timer service will have a callback into our system to check, have we paid out the driver within the SLA. So this allows us to catch all the individual cases where somehow our processing is slow and we're late. So these are some of the techniques that we use to build a reliable payout system. Please let me know if you have any questions. Thank you.
Thank you so much, Jordan. Just to give you a sense of scale, we process billions of dollars on our platform. And every time there's even a 30-minute delay in payouts, we get tens of thousands of emails and calls in our call center. So this is super important. We take this job extremely seriously here at Lyft. Like, we have a dashboard where we sit where even if there's a single payout that's delayed, which is out of SLA, we track it and we have on-call engineers who go and ensure that the payout's done. Next, I want to invite Byron from the Netflix team. They have a different set of challenges. They're going to talk about payments testing. They provide payments across the globe. And Byron, over to you.
Hi, thank you. All right, this is the first time I'm holding a microphone outside a karaoke bar. So, here we go. Ready? Today, I'm not going to talk about A/B testing, even though Netflix does a lot of A/B testing. Today, I'm going to talk about how we improve quality and reliability for the payments team at Netflix. Yes, I'm Byron, and I manage the quality and reliability for the payments team at Netflix. For the last 7 years, I started 7 years ago. For the last 7 years, when I first joined, I was like, whoa, there's so many production problems. Production payment problems, and it affected like maybe 10% of the customers at that time around. And then it happened so often. I was like, oh my God, But today, yeah, we still have some problems, but the scale is much smaller, and it rarely happens. Maybe we have production problems that affect maybe less than 1/100% of the customers. So that's a factor of 1,000. How did we make that 1,000x improvement in quality? I'll tell you. It's nothing that you don't already know. Yes, we did it with a CI pipeline, unit tests, integration tests, canaries, mocking, dashboards, and alerts. All right, maybe some of you engineers don't know what I'm talking about. I didn't expect you guys were going to be here. But anyway, so each of these incremental improvements, if you look at it, you will say, meh, it's no big deal, and you are right. Each of them is no big deal. But if you combine all of them together, it makes a big impact on quality, on improving quality and reliability. And why is improving quality and reliability important? Because it lets me sleep at night, it lets me go to the gym and exercise, and it lets the developer develop features faster, and then attracts more customers and bring in more revenue for the company. Also, with quality and reliability, it reduces the volume for the call center. So in actuality, improvement with quality and reliability has a direct impact on the top line and bottom line for the company. So the takeaway from today's talk for me is 3 things. 1, quality and reliability is important. 2 is that incremental improvements matter a lot. And number 3 is that now you get a sense of what it's like to work with me and the payments team at Netflix. So, #Netflix everywhere. You can sign up, and you can stream, and you can chill anytime, almost anywhere. But you cannot do this 7 years ago when I joined. 7 years ago, we were operating only in the data center, and we were only in half a dozen countries, and we only had 20 million customers. And like I said, we had a lot of production problems. Production problems arrested our development. We had problems like duplicate charges, delayed renewals. We charged customers and we put them on hold so that they couldn't even enjoy our shows. So this generated a lot of CS calls, and it put us in a constant mode of damage control, and it was generally a bad customer experience. So we had to do something about it. We went on a mission. The company went on a mission to grow from 20 million to 100 million customers. Yesterday's quarterly earnings report says we have 137 million customers. The team went on a mission to scale the application so that we can scale the application for the expected growth. And then I went on a mission to ensure and improve the quality and reliability while we migrated from the data center to the cloud, launched globally, and integrated with so many payment processors, I can't even count how many anymore. So if today we had the same scale of problems that we did 7 years ago, 10%, affecting 10% of the customers, 10% of 137 million customers today is a big whopping number. And if it has to do with money, it's just unacceptable. So we need to figure out what the problem is and fix it. 7 years ago when I joined, we were hand packaging, building, and deploying, and then we weren't even confident in the builds we were deploying. I became the CI pipeline, and I was not scalable. So the first order of business is to scale, to automate me. To automate the CI pipeline. For those non-engineers, CI pipeline means continuous integration. And then we need to add confidence to the builds we were deploying by adding coverage and test cases. and add more test cases. Keep on adding test cases. This here is the basic CI pipeline. Everybody here, every engineer here knows what a CI pipeline is. When a developer commits code, then a Jenkins build is triggered. The build runs a bunch of unit tests, and they pass, right? And then 2 Spinnaker pipelines are triggered. Spinnaker is an open source framework that Netflix uses, and we actually created it, to deploy to the cloud. Here you see a bunch of green squares. Each green square represents a test suite. Each test suite represents a bunch of test cases. And green is good. So we are ready to go to production, right? But no, we are in payments. So when we go to production, we need to be extra careful. We go out with canaries in the coal mine. So we do that for 20 hours. We perform automated canary analysis on it. Every 30 minutes, the canaries get a report card. This one got an A, so it gets to live for 20 hours. If it doesn't get an A, we kill it automatically. When we first started with canary analysis, we started benchmarks against system metrics, and that was good because it caught a lot of performance issues. But then we have a mindset of improving. So this wasn't enough. So we added benchmarks against business logics like transaction types, and that made it a lot better. But since we are in payments, we want to be extra careful. So our next phase of deployment would be orange is the new black deployments. At Netflix, red, black, half, 50-50, whatever you want to call it. We call it orange is the new black deployment. And so we keep it here for a few hours or until we feel comfortable. And if everything goes well, we scale up. So now we have a CI pipeline, and I have more free time to go exercise and drink coffee. But a CI pipeline is just a pipeline. Without coverage, it's nothing. How do we get coverage? In my team, we have 10 developers, and then there's me. I'm not going to write all the test cases. So what do we need to do? We need to get the developers to write the test cases. Luckily, developers are very familiar with writing unit tests. So if we get the developers into the mindset of writing unit tests, then we have that coverage there. But we all know that just because all the unit tests pass doesn't mean that the application is bug-free. Nope. Sometimes all the unit tests can pass, and still the application doesn't even start up. So we need another layer of protection. We need a layer of integration tests. We'll talk about mocking later. So with integration tests, it's slightly different. It's different than unit tests. Integration tests are test cases pretending to be the application, making calls to the application. And the integration test framework may not even reside in the same place as the application's project. So since it's so different and the developers aren't familiar with it, how do we get them to write integration tests? Well, we need to make it easy. How do we make it easy? Well, we can make it data-driven. Here's an example JSON blob. It's not the entire JSON blob, but it's just an example of what the developers can write. When they write something like this, then a bunch of existing test cases will run. And here's an example of a test case that injects the JSON blob that the developers write. Then this is using TestNG annotation, very basic stuff for engineers. So this works great for the normal case, but sometimes you have an integration that's very different. So what do we do? Here comes me. I need to write the first few test cases and do the necessary refactoring such that new test cases can be written in JSON by the developers. Then it makes the integration tests, writing them, scalable. So we have CI pipeline, unit tests, and integration tests. We are on a roll. But sometimes, not sometimes, You deal with third-party processors, you deal with third-party vendors, you deal with third-party whatever. Third-party whatever can be unstable, especially in the test environment. And so, but just because they're unstable doesn't mean that you can't be unstable, because you have upstream clients depending on you. In this diagram, we have 4 upstream clients. We have more than that in reality. In this diagram, we have 4 upstream clients depending on payments team, us, and we depend on 4 processors. We have more than that in reality too. So processor 4 in red, if it's unstable, then if the upstream clients get routed to it, they will feel the pain of that instability. We cannot let that happen. So that's why we need to mock it and isolate it. The added benefit of mocking is that if the upstream clients debug and find a problem and they come to us and we're like, hey man, or hey woman, there are problems, everything is mocked down here. So what do? They know they need to go back upstairs and figure out what's wrong. The first approach to mocking is to have runtime overrides. Here you have example of YYY processor, status set to approved, reason code set to 0. This is great, but it needs to be improved because the scoping is too wide. If one team is testing approved scenario and another team is testing declined scenario, then they will collide. So we improve upon that because we want to keep on improving, and we created mock with overloaded names. Here you can see first name is overloaded with approved for status, and last name 0 for reason code. This is great for UI, manual testing, and API testing. But of course, it can be improved again. The reason it needs to be improved is that some processors, some features don't have names in the transaction that we pass to them, like Apple Pay or 3DS. So, by the way, don't try this at home because it will not work. It only works in our test environment. So our third approach, improvement on mocking, is to inject attributes to the POJOs. The upstream clients can pass this down to us. And when we created this feature, we thought, wow, this solved everything. It's so great. But it got lost in translation, and our upstream clients thought it was too complicated, and nobody used it. So in Netflix, we have a culture to encourage trial, just innovation, just do whatever it takes to improve. And this is a great example of where we did everything we thought was right, and nobody used it. It failed. But on our fourth attempt, fourth iteration of improving mocking, and it's the most recent one, we created a mocking service whereby the upstream clients can post payloads to set the expected behavior they want. And then when they make a call to our payments application, our payment applications checks if it's in the test environment, if mocking is enabled, if the record that they had set is in place. If it is, then return what they want, expected. If it's not, go back to the default flow, workflow. So now we have a CI pipeline, unit tests, integration tests, and mocking. Bam, 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 bam. We are very close to good quality and reliability. But sometimes you have a problem in production and you want to debug it. But you can't debug it in production. You want to debug it in the test environment. So, like you want to turn on like more verbose logging, or you want to walk the debugger through it, whatever the reason is, you need to do it in the test environment. So what we do is we clone the data. For many years, we have been cloning the data from production to the test environment. And this was great. It worked well until it annoyed us. The reason why it annoyed us was this cloning was in a cycle, like once per week and sometimes once every 2 weeks. And this, like if you had a problem in production today, that data isn't in the test environment. So what are you going to do? Bang your head or wait until the data is synced? And then another reason why it annoyed us was that, say you have found those production data in the test environment. Yes, we cleansed the data, so there's no privacy concern. So in the test environment, so you found those data, and now you wrote test cases to operate on it. Each time you run the test case might actually well change the data. So before you know it, after 1,000 iterations of these test cases, those test data are no longer valid, or they no longer fit the test scenario that you're looking for. So this strategy is not scalable. What do? We want to improve. It's all about incremental improvements. So we want, the new innovation is to move away from cloning and into creating data. The way we do that is by fronting or pairing each application microservice with a test service. The idea being that the test service that's paired to the application microservice understands all the complicated business logic in the application microservice and can find a loophole and then set the test data the way it wants to set, even if it doesn't make sense in the normal workflow. The reason why we need to do this is in production, sometimes you have like an intermittent bug, or like you have a bug that maybe you have fixed, whatever. So there's data in production that don't make sense at all. Now you want to have that data that doesn't really make sense in the test environment. So this will help. All right, 7 years at Netflix. What a long journey of incremental improvements. The reason why I like working in my team, in my company, is because we have a mindset, a culture of improving, and we kept on improving. When I first started, we had problems that affected maybe 10% of the customers, and I somehow managed to bring that quality up and reduce the errors down to maybe less than 1/100%. On top of that, we had, back then, we were only able to deploy maybe twice a month with very little confidence. And now we are able to deploy many times a week, like so many times a week I can't count, with much more confidence. So, but there's still always room to improve. 2 areas that we can improve on is with dashboards and alerts. And I will leave those as cliffhangers for you to watch the next episode of us talking. Thank you.
Thank you so much, Byron. With so much energy on this stage on a payments tech talk, I wonder how you'd be in a karaoke bar. I'm going to take you next time out to a karaoke bar. With that, I'll hand over to Mike from our fraud team. We're going to talk now about how Lyft thinks about fraud and fraud management, and also the tools we have built to manage fraud on our platform. Over to you, Mike.
Hey, everybody. My name's Mike. I'm a software engineer here at Lyft. So I've been here for about 4 years, and in that time, I've worked on the identity teams doing account security stuff and identity stuff, and the fraud team doing fraud stuff. So I've seen my share of risk. We're going to take a detour from infrastructure today to talk about fraud, give you a high-level overview of like what the fraud team does, who is committing fraud, how are people abusing Lyft. So without further ado, let's get into it. Very high level, like I just said, we'll talk about what is fraud, what does it mean to us, who is doing it, get a little bit into how we fight back, and talk about what we're planning for the future. So first off, what is fraud at Lyft? We're going to talk specifically about financial fraud, and this means that like it's when we lose money from people exploiting loopholes or using deception or actually committing criminal activity. And so this usually manifests to us in 2 ways. There's failed charges, which just happen immediately. You try to charge the card, and immediately the card doesn't have funds, or you get a decline from the bank. That one's pretty straightforward. It also happens as chargebacks. And this happens when someone sees their credit statement, maybe 2 months later, calls their bank, says, oh, I don't recognize these charges. Please take them off. So the bank will refund the money, and we're on the hook for that, so we have to give the money back. This presents some interesting problems because, like I said, we don't have this data for maybe 60 to 90 days from the actual charge. So that makes training models hard. We'll get into that a little bit more. But let's talk about the types of people committing fraud, or at least the types of things that we've segmented fraud into. So our first category is the casual fraudster. These are people who are not necessarily evil at heart, but who's going to give up a free ride if they can get it? So friendly fraud. This is if, in the previous example, we talked about chargebacks. Someone decides, oh, they took this ride, but they don't like it. I'm going to call my bank and say, hey, no, I don't recognize this charge. Please give me the money back. This is an example of friendly fraud, and it's up to us to provide evidence saying, hey, they did take the ride. Here's the details about it. We don't owe the money for this. The next category is just sort of product exploits, things that if engineers code in loopholes, like for instance, if I can get infinite coupons by exploiting something, people might consider that a victimless crime, like, oh, Lyft's a big, large corporation, they got a lot of money, I'm just going to skim a little off the top. We have to shut those down because they can get pretty big pretty fast. The next category would be organized crime. So these are the people who are actually committing crimes. At this point, you're buying stolen credit cards off the black market or something. You've crossed a threshold. And they might take these cards and do long-running joyrides and the Lux ride mode and things like that, racking up huge bills, rides for hours, tying up our drivers and causing a lot of loss. This also manifests as people trying to do account takeovers. So our drivers are our customers too. They earn money on the platform of giving rides. People try to phish them and get their credentials from them so that they can break into their account, withdraw funds to their own card, things like that. So we use a lot of the same systems that we use to fight fraud. To fight this sort of identity and account security issue, we want to prevent that login from happening. We want to prevent that payout from going to the wrong person. And the last category would be commercial scale fraud. So this is when you're up against basically another engineer. You have someone at the other end building tools, building sophisticated pipelines to actually exploit your system. And these are very technically sophisticated groups, and it's an entire ecosystem, actually. So it's estimated there's a 1 million person fraudulent industry of just vendors and tool groups, people actively hacking and stealing credit cards, selling those credit cards, running click farms, running fake account businesses where you just, you go to a company, you buy 10,000 fake accounts, and you operate your business based on that. And these guys make you really good at fighting fraud and making sure your platform is secure. They keep you honest. They've got access to immense resources, and so it's a very, it's a big fight. But we have a small engineering team, and we're actually able to put up a pretty good fight of our own. So who are we? The fraud team is very cross-functional. It's broken up into about 4 different groups. We've got research science, data science, risk ops, and engineering. Who are those? So research science, these are the guys who are writing all the machine learning algorithms. They're doing a lot of R&D. So research science, specifically in fraud, actually, has pushed a lot of boundaries for what Lyft is capable of doing in a machine learning sense. They shipped some of the first deep learning models, and we saw huge gains from that. So there's really exciting stuff going on at research science, specifically in fraud, all across Lyft, obviously, but big shout out to our RS team. Data science, now these guys are digging through data and sort of coming up with a high-level strategy. So if you look at all the loss that Lyft accumulates as a company, what are the different categories of thought? Not just the 3 that we talked about previously, but what are the different types of vectors? How do we prioritize this in a way where we can actually figure out what engineering things we can build to have the most bang for the buck? Which types of fraud can we knock out in what order? Now, risk ops, this is a lot of operations, lots of review, looking at the actual ways that people commit fraud, digging into specific user accounts. Okay, this guy incurred loss, this guy incurred chargebacks. How did he do that? Is he exploiting some weird PayPal bug? Is he triggering some weird decline codes? Actually finding out what that's all about. And they'll write individual fraud rules. We talked about machine learning. That's a huge part of our fraud pipeline. But it's important for ops to be able to define human understandable rules so that you can put out small fires as they come up before they become big fires. And then engineering, of course. So we're the ones building the platforms that enable all the other functions. Lots of platforms and tooling, for instance, to run the machine learning models in real time, to do all the feature collection, to enable this platform so that random ops agents can ship rules. It's our responsibility to enable that. And we also do all the product flows. So a big thing we do is, hey, if you look suspicious, we're going to ask you for some more information. We not only build the flows that users go through to do that, but we also build pretty sophisticated platforms behind those that make sure, we can serve random flows at a moment's notice. We can ship something in a week that used to take 2 months to build. We build the platforms that facilitate all that and make it easy. All right, so at a high level, what do we actually do to combat fraud? Speaking very generally, we take very specific trigger points in the app, things that are potentially risky where you might incur loss, like requesting a ride, changing your payment method, logging in, and we run fraud models around those. At a very high level, that's a lot of what we do. And depending on how you look, if you look super fraudulent, maybe we just block the operation altogether. If you look sort of gray area, maybe we'll give you a challenge to collect more information about you. Hey, prove to me that you're this person, that you are who you say you are, and then we'll let you take a ride, stuff like that. Prove to me that you have the funds, et cetera. And if you look, like, more than 99% case, you look fine, and we'll just let you go. In the slight gray areas, we might also just flag your account for someone to actually manually review it later. Obviously, that doesn't scale too much, but it happens. The key component about this is that you always optimize for good users. We're a transportation platform, and people rely on us to get around, to get from point A to point B. And so people are literally like using this to go to the airport, get to their jobs. And so false positives are really expensive. They're a really bad experience, and they're disrupting someone's lives. So we always want to make sure that you have a path back to the platform, that there's something you can do to get that ride if you really need it. And so this means we hold ourselves to strict SLAs. We adopt philosophies like failing open. If we can't get a fraud score in time, we'll just let you through, things like that. And it keeps us honest. It means we have to be really good at what we do if we actually want to fight fraud. Cool. So let's talk a little bit about the tools. You can think about the fraud platform in sort of three main responsibilities. Number one, ingesting features. We need to know who you are and able to like make some decision about if you look fraudulent or not. When I say who you are, I mean like what your user account looks like, not necessarily like in detail. I'm going to go to your house and like figure out like all your PII. And then we want to make a decision based on the data that we have. And this is the machine learning and the business rules that I talked about earlier. We have to build that platform. And then we want to serve some sort of challenge. If you look fraudulent, we need to collect more info. Now, the one caveat, we're doing a lot of talking about like prediction, running machine learning models. That's only going to mitigate fraud. And that's not going to necessarily solve a full solution. You can do all the prediction you want. At the end of the day, you're predicting the future, and that's hard. So if you build product changes, you can actually stop fraud altogether sometimes. So very small example, Lyft 4 years ago launched Lyft Line, shared rides as it's now called. And there's this interesting feature. So the passengers always pay the same fare up front. We give you a price quote and you pay it. And then the drivers are paid whatever time and distance they do for the ride. And so it felt like this victimless crime where drivers would take the passenger where they want to go. And if they don't have another passenger lined up, they'll just keep the ride going, for another 2-3 hours. We end up paying them for that 2-3 hour difference, and we cover the difference. The passenger pays what we promised them up front, but we end up paying the driver out like 10 times more. Now, we could try and predict, hey, which drivers are going to do that, which guys are like abusing the platform, or we could just change the product so that, okay, we'll just cap the amount we're going to pay the driver based on where the ETA is supposed to be. And people who were abusing the system picked up on this and realized they couldn't do this anymore, and the fraud essentially went away, or that specific vector went away. And so sometimes it's just better to change the product to holistically solve a problem. You don't need to invest a ton in finding signals and predicting the future. But anyway, we are going to do that because we need to do that. So let's get back to it. There we go. Okay, so we're going to talk about ingesting features. So this is roughly what the pipeline looks like at a very high level. Lyft is a microservice architecture. We've got hundreds of different services running at any one time. And they all were very data-driven companies, so of course everyone is firing different events to describe how users are using the product, what products they're interacting with, what frequency, et cetera, stuff like that. So this all flows through some standard event pipeline, and it goes into a big data warehouse where we run nightly ETLs so that analysts can run their queries and get data. And that's very useful, but it's on a 24-hour cycle. So like we run this nightly ETL, we don't necessarily have that data. So if someone's going to sign up an account and go from making a new account to taking a ride in 60 seconds, we actually need to know that now. So we subscribe to this real-time event stream to pick out the specific events that we find to be interesting. And this is better than just like, one suggestion might be, oh, well, why don't you just call all the other services? Like do 50 different service calls to collect data. That doesn't scale extremely well. It gets like, it puts different services have different SLAs, like they might not get back to us in time, they might have high latency. And so what we ended up doing is listening for the events that matter, collecting them ourselves within our own service so that we have access to the weird esoteric data that we might want without burdening the other systems. So we listen to this event stream in real time. We see all the events within a couple seconds of when they happen. And they run through a record processor, which basically does simple aggregation. For instance, if we want to know how many rides you've taken, we just increment some counter based on some ride request event. If we want to get more complex and say like, hey, how many dollars in the last 90 days have you spent on this debit card or on a debit type card, we can do aggregations like that and store them in some windowed counter repository. Or if we want to do really complex stuff that doesn't really fit into stream aggregation, like, all right, you've just finished a ride, you got dropped off. We want to look at the last 10 rides and calculate the time it took to get between those different rides and see like, oh, you crossed New York and now you're taking a ride in Utah, something's up there. And we need to do expensive calculations essentially. We run that through some different system and then we store it in some arbitrary key value store. So we use Dynamo for this. And rather than setting up a bunch of different tables, fraud needs to move pretty quickly, so we just have one giant KV store for certain things, and you can just throw random data in if it becomes useful, and pull it out later to do real-time fraud decisions. Okay, so that's real-time features. We also use slow features. Now, you might think, why do you have this slow feature system? You have the real-time feature system. It turns out that it's much easier to build stuff. So like, the real-time feature system requires some engineering work. If you have a feature, some engineer needs to go build it from anywhere from like a day to a week to 2 weeks, whatever. Slow features are actually just SQL queries, and you can have an analyst do stuff like that. So the way this works is we use the same data, same events that are being sent, they all go into a warehouse, and we just run queries periodically that go and collect those features and make them available in real time. So pretty straightforward. It's basically running a cron job, or you can think of it as that, and running features and collecting them for production. And this is slow-moving stuff like how many iPhone users were fraudulent, what percentage of people using an iPhone and using like a debit card were fraudulent yesterday or over the last month, things like that. Things that are like very natural to write SQL queries for. And this provides a lot of easy observability into it because like our ops agents are all very familiar with SQL. They can understand these queries, they understand what the features are doing. We don't have to do a lot of expensive engineering work to go and facilitate this. So this has actually worked out pretty well for us too, surprisingly. Cool, so let's talk about what kind of signals are interesting. We do maintain a user graph of users who are linked by devices, different payment methods. If you have 100 people sharing the same phone, that's really interesting. We also have physical features. So like, it's really important that your users obey the laws of physics. So like, number one, if I see you in New York, and you just finished a ride there, and now 5 minutes later, you're taking a ride in Utah. Number one, how did you break the sound barrier? Number two, why are you even using Lyft? It seems like you've got transportation figured out. It's very suspicious at that point. You probably want to flag the account. And that sort of leads into using characteristics of the fraud vector that are pretty essential to that fraud vector. And so that means that you want to choose signals that are hard to spoof, really. So like Lyft requires a verified phone number, which means that we know the carrier associated with that phone number. We can figure that out. And so, if you're using a VoIP phone or if you're using a common burner phone number, that makes you look suspicious, things like that. Or if you're using, depending on your IP address, if you're outside of the US, you need to use some proxy to make it look like you're coming in from inside. And it's more expensive to get non-fraudy looking IP addresses from respectable ISPs, things like that. So you want to choose characteristics that are hard or expensive for adversaries to manipulate. And the next thing is behavior. So just how people use the app, tracking that data, like timing patterns, things like that, is very useful to machine learning models. And then there's something we call MIDI models. Those are sort of what I was alluding to before, where you say you have a ratio of people on this type of device, this type of care, things like that. Just those simple types of ratios become very powerful. And again, very easy to understand, which is kind of a bonus. And then also everything else, as it turns out. So it's, if you have really advanced machine learning algorithms, you can just throw whatever features at it, as long as you can get it into an understandable format. And the nice thing about that is that, especially with deep learning, the algorithm will figure out different types of relationships between features that it might be very expensive to build yourself manually. So for instance, if I want to do something like, oh, if you sign up and then 5 seconds later you've added 5 credit cards and then you take a ride, 30 seconds later, that's potentially suspicious that you have so many credit cards on hand and you're really desperate to take this ride. You don't need to go and build those features. Like, you need to build the very high level usage statistics and then throw it at the model, and the model will figure that out if it's useful. So that saves a lot of time. You do have to invest in RS for that, or research science, but it's very powerful. All right, so that's a lot about ingesting features. Let's talk about making decisions. So machine learning, this is a huge one. We have a number of machine learning models at different points in the app, and they are a large majority of like how we flag accounts for suspicion. They're really effective, but they're kind of slow to train. So like I talked about chargebacks earlier. It can take 60 days for a chargeback to make it into our system, which means there's 60 days where we don't know if we should say this person is fraudulent or not. You need to label all your data, so in order for the machine learning models to figure things out. So it's not yet suited for like if someone starts attacking you tomorrow and you're incurring huge losses. They're not well suited to fighting that sort of problem. I'm not going to go too much more in depth into machine learning. There are actually some great blog posts you should read by one of our prior research scientists, Hao Yong. He's moved on from the fraud team into a driver team, but he really pushed the boundaries for research science within the fraud team. These are great articles. They'll walk you through the history of machine learning at Lyft, how we went from like linear regression models to new deep learning, and really get into depth about the last bit about deep learning using behavior fingerprinting. Sorry. Really recommend those. eng.lyft.com. Go check it out. All right. And the other side of machine learning is, or on the other side, other end of the spectrum from machine learning, we have business rules. And so instead of firing like 150 features at a machine learning model, you have a human come in and build like a 5 or 10 feature business rule. And these are really easy to understand. Generally, here's an example rule. This is terrible. This is not something in production, but if I'm in SFO, which is San Francisco, and I'm using a VoIP phone, and I've spent less than $100 in the app over the course of my lifetime, maybe we should serve you a challenge. Again, this is a stupid rule, but it gives you a flavor of like what it looks like. This is something that random agents would be able to put together. And then we can make it a little bit better using those ratios, the mini models that I talked about. Okay, we can still do some basic aggregation, figure out who looks fraudulent based on categorical signals, and then challenge you based on things like that. And again, these are great for fires. These are great for putting down targeted fraud segments. They're not great for being the brunt of your fraud platform. So let's get into some of the trade-offs like I was talking about. So models, again, high precision, high recall. You can train your model to be extremely precise, and you get great results from that. It detects interaction features, but it's slow. Like if someone starts defrauding you for X million dollars tomorrow, a model is only going to help you, like at minimum, within a couple weeks, probably. Rules, on the other hand, they give you pretty quick reaction time. You can start writing stuff and like fighting that immediately. The problem is once you do that, you've built up this huge catalog of rules, and it becomes difficult to maintain. You need a lot of process around it. You need to like go in and weed them out, figure out, okay, now that you've got this rule that was effective at stopping fraud, the fraudsters have gone away, and now it's really effective at stopping good users. We need to trim those out. So there's a cost associated with both. And making decisions. Okay, so serving challenges. Sorry, I messed up the slide, but serving challenges, basically. Too many slides. Yeah, so I'm not going to talk too much about this because we're actually trying to do another presentation coming up. We've built this really cool challenge platform recently. So it used to be that we had to take 2 months to ship a new type of challenge. When I say challenge, an example is just give us, say, your billing address or something like that, your date of birth, and we'll run some extra fraud check on it in the background. And you have to go in and you have to update the app, or you have to do some lame web view, and it's a terrible user experience. And the user goes through this, and they'll probably churn because it's not a good experience. But we've recently written a platform so that we can control. We can ship challenges via the server, and the client will go up and read them and run the user through a whole flow. And it's completely server controlled. So the client's got a bunch of logic to listen to what the server is going to have us run the user through, and it just pulls all that down and it runs them through whatever arbitrary flow we give. And this is pretty exciting because now you can have a very clean, native in-app experience to do all your challenges without the 2 months of work. It takes maybe a week. So we're hoping to have another tech talk about that. In the meantime, go read this other blog, Stopping Fraudsters by Changing Products, by a previous fraud engineering manager. Pretty exciting, and it talks about our philosophy for how we think about challenges and how we think about letting people make sure they can take rides and get back onto the platform. Cool, so real quick, let's talk about the feature. We're running out of time. Automatic feature discovery. So Lyft is growing. Like I said, there's hundreds of different services out there, tons of different products. We can't manually sift through all the data and figure out what features make sense, what features even make sense just to feed into the models. So we need our own discovery algorithms to go out and find those. Challenges anywhere is what I was just talking about. Not only have we written this cool challenge platform, but it's applicable everywhere. We don't even have to write a hook into the app to tell you we might challenge you here. It just happens automatically based on request headers. Pretty exciting stuff. And then building client signals. We want to know if you're spoofing the app, if you've jailbroken your phone, stuff like that. There's a lot of vendors that do that. We need to do it in-house for a lot of reasons. But there's some pretty, if you're like really into hacking the client and like getting deep into the hardware and stuff, there's some pretty interesting work going on here. And in general, expanding our risk platform. So we've built all these systems. They're really useful for fighting fraud and doing account security stuff. They're useful in other parts of Lyft, so we're taking what we've written and expanding it across so that it's useful to others in the company. And yeah, if any of this sounds interesting, surprise, we're hiring. So please come find us and talk to us. All right, thanks very much.
Thank you so much, Mike. We'll take a quick 10-minute break. The key goal here is to just meet other people, talk to folks. Don't even think about leaving because we have 2 more exciting speakers right after that. So we'll start exactly in 10 minutes. Thanks.
Hello, everyone. Hope everybody had a great break. I'm CG from Financial Infrastructure team. I have been working with Lyft for over 2.5 years. Today, I'm going to talk about building the next generation financial infrastructure. I know this might be a boring topic, but I'm going to try to make it as interesting as possible. Before I dive into the topic, let me go over a bit of Lyft history so you guys can have a better understanding about the reasoning behind the work. Lyft was founded around June 2012. It was so hard for the first year because not many people were using Lyft. Therefore, there wasn't too much traffic. And the data volume is so low that a scalable data warehouse is not needed, or at least wasn't a priority. Everybody thought we were going to be crushed by our competitors, so engineers didn't really plan for the future. That's why we were trying to buy things off the shelf instead of building something that lasts longer. Also, because our tech stack are mainly on AWS, so we chose Redshift as our main data warehouse. At the beginning, financial reporting is simple and straightforward. We only have one data pipeline called M2R. It stands for Mongo to Redshift. We copy data from Mongo to Redshift and then run some simple queries at the end of each month. Problem solved. As for data accuracy, as far as the number looks good, we're OK with it. It's just for the record, we do have unit tests, integration tests, and financial data validation process in place now. I joined Lyft around early 2016, and just a few weeks after I joined, things got real. Rides grew a lot, and data grew 100 times in the next 2.5 years. And whoops, I didn't think we ever expect this kind of growth. Something must have exploded. Yeah, that's right, Redshift exploded. Not only because of data growth, but also because of the number of backquery people are running. To stabilize the Redshift cluster, several short-term fixes were used. First of all, we are adding more nodes more proactively, and we are doing vacuum during the weekend. Vacuum is basically a process that reclaims some space and to improve query performance. But it's very expensive, so we have to do it over the weekend. Also, we create a smaller read-only Redshift cluster, but this requires constant data replication from the main one, which is not ideal. We also actively killing backqueries and yelling at people who issue them. In addition, we hire a few Redshift experts to optimize the daily ETL job, hope to squeeze the last bit of resource out of Redshift. However, Redshift is like a sinking ship. Short-term solution can barely keep it afloat, and still more and more people trying to get on board. I don't remember how many nights I was paged because of Redshift, and I don't want to talk about it. In the meantime, we also came up with a long-term solution to migrate our entire data warehouse to Hive and Presto. Data warehouse migration is never easy. The big migration started early 2016, but it's still in progress. As for the financial organization, they desperately need a stable cluster to do their financial reporting, to calculate tax, and to show number to investors. And Hive migration seems going forever. So we decided to create a dedicated Redshift cluster called R3 just for the finance org, and migrate only the financial data to it, which is far less than the total data volume. The isolated cluster also has several other advantages. For example, less people are trying backqueries, and it's much easier to lock down our sensitive financial data. Over time, this Redshift cluster has become the main data warehouse that supports all the financial needs till this day. Some of the most critical data pipelines have been running on top of it, including M2R and D2R. We bring data from Mongo and Dynamo to Redshift 3 every day so that people can do data mining, analytics, building reports, metrics, and finally make some decisions. After daily run of M2R and D2R, we also do data validation between the source and destination cluster to make sure that there is no data loss and downstream consumer can always trust our data. Since we are doing this kind of data validation, such data has become the source of truth for many, many metrics at Lyft. That's why we also replicate out to Hive and Presto and other Redshift cluster for other teams to build their own metrics. Secondly, we ingest internal data from our third-party vendors, such as payment process partner, express drive partners, and other partners. We do a data reconciliation with our own data in Redshift 3. This is crucial to our financial health. Without these pipelines, we can never know if we get overcharged or undercharged by our vendors. Most importantly, financial reporting pipelines such as month-end close, daily spend reports, and tax calculation are running on this Redshift cluster. This pipeline provides us with a financial number that truly reflects the health of Lyft's business. And also some of the report even sent out to investors, auditors, or government agencies. However, although Redshift served us well in the past, but it never designed to be a petabyte scale data warehouse. If our financial data continue to grow exponentially, we will soon reach its limitations. Like traditional distributed database, Redshift is made up with one or more nodes. Each node has limited resources such as disk, memory, or CPUs. This also means that storage and compute are deeply coupled. There is no way to separately scale up either storage or compute. The worst thing is that resizing is a very, very painful process. It requires hours of downtime, and it's disruptive to our day-to-day pipeline. A large Redshift cluster can take days to scale up, and we have to do it over the weekend to minimize the impact. As you can see here, it takes about 16 hours to just add 4 nodes. And using Redshift require huge upfront investment of hardware. Redshift isn't cheap, and we have to overly provision the cluster in order to satisfy the future growth. Yeah, basically, we had to buy more nodes at the beginning to avoid this painful resizing process. each node of Redshift is a single point of failure. That means if one node goes down, the entire cluster will be out of service. And usually takes hours to recover. As a side effect of resizing is the increased probability of the cluster going down. In addition, Redshift has a very weak resource isolation mechanism. One bad query can screw up the entire cluster. And data cannot be ingested in real time. We have to do it in batch, usually once a day. That means there will be at least 1 day delay between before the freshest data can be queryable. And last but not the least, data in Redshift is not compatible with Hive and Presto. We need to set up dedicated replication pipeline just to share the data between the systems. To have a long-term solution that addresses all the limitations in Redshift, we have laid down several requirements for the next generation financial infrastructure. First of all, due to the complexity of big data solution and limited resources, it will be wise if we can leverage something that's already available, either from AWS or from other teams, and instead of building it from scratch. And we also want to decouple the storage from compute so that each can scale up and down independently. And the new infrastructure should ideally be support heterogeneous storage and compute, which means we can have cold storage for the legacy data and have the dedicated compute power for heavy ETL. We don't want to pay for the hardware just sitting there idle. If we can pay whatever we used, it will be very cost efficient. Real-time ingestion is wanted by many, many customers so that they can detect their production errors much early or make some quick decisions. We also want the new infrastructure to be compatible with Hive and Presto so that we can avoid those expensive data replication pipeline across the systems. Most importantly, we still want to have a good access control that is comparable to Redshift because we still have sensitive data to lock down. To build the next generation financial infrastructure that satisfies all the requirements, we have experimented with various available options and gauge their pros and cons. I'm going to focus more on cons here. First option we were thinking about is joining the big Hive migration and Presto migration I talked about earlier. However, there are several problems that just cannot satisfy our requirement at all. The first one is the cluster management is through Scalable. Scalable is a third-party vendor that also provides software to us, which means this things just cannot satisfy the data security requirement by the finance team. We also look into Google BigQuery. After some experimentation and discussion with ex-Googler, we decided not to use BigQuery, even though it might be a good option. That is because BigQuery is on Google Cloud Platform, and our main data warehouse is still on AWS. So it means you will still require constant cross-data center replication and validation if we go with BigQuery. In addition, there is no official support for BigQuery at Lyft. And the third option we look at is Spark on S3. The major concern for this solution is Spark is still an in-house project that's just getting started. It might take months to get stabilized and to be able to support production use cases. And also, setting up proper access control on S3 is kind of tricky. In the end, after weighing all the pros and cons, we have decided to use S3 as our main storage layer and Spark as our main compute engine for the following reasons. S3 is infinitely scalable and highly reliable. And there was only one major incident in the past few years. And supporting real-time data ingestion, as long as we don't hit the rate limit, we can ingest data as fast as we want. And data on S3 can be directly accessible by Hive and Presto. Although the access control on S3 is tricky to set up, but the functionality is fairly comparable to Redshift. Most importantly, Lyft has a dedicated team to support our use case on S3. As for Spark, it has been proven by the industry to be suitable for large-scale ETL. I know that Netflix is using Spark for their ETL pipelines. And it's dynamically scalable, which means if suddenly we have more workloads, Spark cluster can automatically provision more nodes. And it has a pretty good trade-off in terms of performance versus scalability. Faster than Hive and more scalable than Presto. Most importantly, it's an in-house solution. And it has been actively developed by a dedicated team at Lyft. So it's easier for us to influence their roadmap, such as asking for new features, asking for bug fixes, and so on. And what's next? Once we have our next generation financial infrastructure stable and ready, we will need to start migrating all the critical data pipelines. And in the meantime, we do have to support new use cases like more partners, more reports, and more online databases. So basically, everything here in the dotted box will be something we need to migrate or build. Therefore, there are still a ton of work ahead of us. So talk to me or my team if you are trying to solve the similar issues. And there might potentially be something we can collaborate on. And thank you.
Thank you so much, Sichi. If you want to keep your CFO happy, you need to invest in your financial infrastructure team. And Sichi and the FinInfra team at Lyft have done an amazing job in keeping our CFO happy. The last but not least, we just want to invite Gigia from Airbnb. Thank you so much for joining us, Gigia.
Hi, everyone. My name is Jaja from Airbnb Payments team. So today's topic is about building a scalable payment system in Airbnb. So this is the agenda of today's talk. First, let me give an introduction of the Airbnb Payments team. So many people might not know, the Airbnb Payments team is, if it's a separate company, it will be one of the largest payment tech companies in the world. Let me show you some numbers. It's been processing billions of dollars per year. That might not sound very interesting. Second is that it supports over 190 countries in the world. And I guess it's maybe by far the largest compared to any other payments companies. And also it supports 40 plus currencies natively. So these 40 plus currencies is we can settle like at the local country, not just if you, for example, pay a USD through a Europe credit card, your bank might automatically convert that to USD. So these 40 plus currencies is a native currency. We settle on that currencies. And also this is also a unique requirement for Airbnb. Almost half of the transactions are cross-border transactions. And last is that we have been integrated with over 20 plus payment processors, and it's growing every day. Okay, so let me talk about some of the challenges you are facing in the payments team. So first, when every company begins, it used to be a monolithic app. In Airbnb, we are calling it a monorail. So basically, everything was inside that Rails app. And there's one file called reservation.rb. It grows organically to 20,000 lines of code. And so almost everything was in that file, like block a calendar to the pay in, pay out, send a receipt, send a confirmation email, you name it. So that included a lot of payments code. So how did we do the charge? It's triggered by reservation to model.save. It's in the after save hook, which triggered the payment charge. So you know how many problems you can encounter for that payment. And also all the pricing data, the coupon, gift credits, all the the data and the numbers are stored within the reservation model. So it's deeply coupled with the product logic and the data. And also for the financial reporting, originally it was just a SQL query run on the online database. So yeah, naturally, as Airbnb grow, we are facing a lot of the scalability problems. So like one side of the scalability is about the horizontal scalability. I think it's where it's established and people already know. Like there are a lot of standard procedures on how to solve them, like how to deal with the storage capacity, the QPS, and the failover. Another area I want to focus more is people talk less about is about vertical scalability. But this vertical scalability is not about the machine because currently everybody is using cloud. So there are very limited options on increasing the computing power on each individual instances. So the vertical scalability I want to talk about is more at the system level. When you have a complicated system, how do you like set clearer boundaries of the services, and also how to make the services to easily integrate with each other. This is an area that has a lot of different people have different opinions, and there are a lot of discussions about like which team owns which functionality and how to cut clear boundaries between these teams and the services. Okay, now I'll talk about how do we approach this scalability problem. So first, this box will contain the details of the payment design. But before we dive into the detail, let me first looking from another perspective. Because usually when people talking about payments, it's so complicated that other teams don't want to talk about it at all. So when we build our system, we always think from the users or the client, our client's perspective, like how do they want to interact with the payment system? So let's say there's a happy customer comes in. The first step he will do is to get the pricing. But this is not one call. It's maybe you might like research 100 different listings. You change the different date, change different location, and until like after like hours of browsing, you finally pick the ideal home you want to book. And then the second step is you click the book button and to book that reservation. And what's the next step? Actually, there's no next step. After people pay, they don't want to interact with the payment system at all. So this is our goal is we will try to at the entry point to the payment system, we want to make it as simple as possible so that the other teams like don't need to worry about any of the detail inside the payment system. So, but what does it look like inside? Let's see. So first, when you do pricing, there are two parts. The first is the payment UI widget, and second is pricing service. So I want to point out the payment UI widget. So why does the payments team build a UI front end? The thing is that payments is hard. Even the front end is hard. Like say when people try to pay a reservation, it can choose to pay by credit card, which you need to render a credit card form, numbers, expiration date. But depends on different card brand, you might render the CVC or other number differently. Also, what if the user want to pay by PayPal? You need to render the email box. And what if the user want to pay by Apple Pay or pay by the payment API integrated with the browser? So there's a lot of details to worry about. And we don't want the product team to worry about all the payment details. So we own this payment UI widget, and we give them to each product team, so they only need to add one line of code to their front end, and we render the whole thing for them. And the pricing service will get all the the price-related data for the product, like the basic base price and taxes and other kind of fees, coupons and gift credits. That it's like a fun fact that on average, a reservation on Airbnb has 12 payment types, or pricing items. So base price, extra guest fee, you have the cleaning fee, host fee, guest fee, VAT tax, toll tax. Like even when you see, you only care about the total number, but underneath there is a lot of details relating to how the total is calculated. So now let's get to the second step. When you book, it's actually you only need a billing service. But after create a bill, there are a few more steps. You need to integrate the pay-in and pay-out. Like we integrate with over 20 plus payment processors. You need to integrate them to do the charge. And for the payout, usually the payout is not instantly. The payout will be scheduled normally on check-in +1. So you need a scheduled service to reliably pay out. And you don't want the product to tell you when to pay out. You want to schedule for them. And last is the finance reporting, accounting reconciliation, ETL pipeline. Usually it's an offline system that I will talk about that in more detail later. So this is the overall architecture. And I will, in the next few slides, I will dive into more detail for a few components. So the first is about the developer portal. Still, payments is hard, so we want to make it as simple as possible for other teams. So we built a development portal. Currently it's internal only, but eventually we will provide this portal for external products as well. So the payments philosophy is that we want to, when another product team wants to onboard a new product, our philosophy is that no code change is needed. So that is our goal. So usually our ideal case is that when another product needs to process payments, they only need a PM. They come in and click a few buttons and then we are good to go. But what if some of the product team need more control on the payment flow? So the first level we give them is we have a dynamic config system. We call it Stargate. We allow them to configure the pricings, taxes, and fees differently. So different products can choose their own pricing strategy and how to calculate the tax and the fees. And for some other even more complicated products like the reservation, it might have deeper integration with payments. For example, it only wants to block the calendar when the pay-in is successful. So in that case, we left a few hooks inside our billing flow. So we ask them to provide us a few webhooks, and we will call them right after, for example, pay-in, right before we do the payout. So for the more complicated product, they can have a better control and over their user experience. And for the rest, we will just do it. After the configuration, the payments team will do all things related to payments for you, like calculating the tax, do the reconciliation, generate the receipts, and also doing the payouts, everything. After they call in the payments, they don't need to worry about all the following tasks anymore. Okay, the second interesting part is about the smart processor routing. So as you know, we have over 20 different processors, and for each payment method, you might have quite a few processors that can support it. Originally, I think all the routing logic is it's static, just depending on the card number, it will be routed to a specific processor. But as the system grows and as your volume grows, whenever you have a processor, for example, if a processor is down, you want to switch instantly to another processor. So that's why we have a new service that monitor the healthiness of the processor and do the switching immediately. Another interesting thing we can do is that because Airbnb cares less about the transaction cost, but more about the user experience. So they want to make sure the first charge acceptance rate is as high as possible. So when we choose a processor, we want to make sure we do choose the one based on the acceptance rate, like for that card number, the user profile, and a lot of other signals to improve the user experience. And next one is about the interaction between the services. So I think maybe a lot of you might have the experience as you have more and more services in the system. And also, especially for payments, most of the requests are transactional. And in a distributed environment, it's really hard to guarantee transaction. And usually there are two ways to do that. The first is to two-phase commit, and second is idempotency. And it's really tricky to implement two-phase commit with a lot of services. And also, we don't want the client to keep track of the state of the transaction. So we choose the idempotency as a general solution for all the payment services. So we make sure every request in the payment services are idempotent, so that when the client doesn't need to worry about the detail at all. Whenever there's a failure, just keep it try until you are succeeded or until you get a response. So I think when you use some other website, you might notice that when you book, for example, book a flight ticket, you might have a plane like circling and telling you, don't click back or refresh button, otherwise you'll be double charged or you'll lose your place. But with idempotency, you don't need to worry about that at all. You can keep refreshing until you get the results. And now about the storage. So for also for payments, the special thing is about payments is transactional. So most of the NoSQL systems are not well trusted in the payments industry. So the most trusted one is still MySQL or Postgres. And last year we have a few instances with RDS. Even we already requested the largest and the most powerful machines for RDS. We are approaching that limit, and it's almost bring down the Airbnb forever. So that's why but AWS currently still doesn't have a solution for the new SQL like the Google Spanner. So before they provide that, so we have to implement our own scalable MySQL solution. So we use the application level sharding. We built that into the juice injection system, so the developer doesn't need to care about the sharding at all. It's all done automatically by the interceptor. And it will allow us to horizontally scalable as much as we want until we have a better solution. And the last is about the financial data pipeline. This is actually one of the first services we built in payment system. So originally, as I mentioned, we were just running some queries on exporting the MySQL database to do the financial reporting. And it gets slower, and until at one point, it takes more than 1 day to generate the last day's financial report. So then we need to migrate to the new system. The main thing we did to decouple the online system and the offline system is that we migrate all the interactions from the database export to events-based system. So for the online system, in addition to write the data, it also, at that time, after everything that's related to finances happened, it will emit an event. And that event is consumed by the finance team. And the finance team uses that event to build the whole financial data pipeline. The good thing is that as the online system is migrating from a monolithic app to a service-oriented architecture, all the databases has been changed, all the schemas have been changed, but the event schema is still the same. So it allows the two teams to iterate on their different pace and allows them to scale much better. For example, even before the online system switched to payments as the SOA completely, the finance team, based on events, it already iterated 3 major versions. So in the first version, they built everything in events, and the second, they built an incremental one that don't need to rerun the whole pipeline every day. And third is that they're integrating with more the commercial finance reporting systems to make it easier to process for the finance team. Yeah, so that's like all the points about how did we scale the payment system. And for the opportunities, we're still in the very early age for the payments as OA. Like the service listed is just like one of the few. We already have at least 10 new services in payments. And currently, we are only supporting 2 major products in Airbnb. It's the homes and the experiences. And after our system is ready, we are expecting to have much more products, both from the inside and from the outside. And because the Airbnb strategy is to build a travel platform for the next generation, and the payments team is trying to build the payments foundation to support the scale of the travel system. And yeah, that's all from me. Thank you.
Thank you so much, Jaja. We just want to open it up for any questions. I invite all the speakers to come on stage to be able to answer any questions. Go ahead. Can we give a loud round of applause for all the speakers? They did an awesome job preparing for this event, rehearsing and giving us really in-depth information about each of the areas. Thank you so much, guys. I'll run around the mic.
Thank you guys. Really appreciate attending this event and share the sentiment. It matters how we get there. I think I have 2 questions, maybe one for Ashwin, one for June. For Ashwin, as the company is growing and you are diversifying your business cases and as you are experiencing certain learning trajectory, I would say, what are the challenges that you are experiencing with your processors and payment gateways, and how are the strategies that you are navigating those, given I would expect that they cannot really match that learning trajectory, if you want. And for June, I've worked for many years with ACH and banks, and I happen to know that NACHA and all the other legacy and clearing houses in various countries have very specific rules and regulations, and there are ways to compel banks. Very specific example you brought up is that there are errors you don't get in time to then, and they impact your back-end models, I would expect. So what specific banks and what specific errors are you talking about? Thank you.
Okay. How long do you have? I thought we were going to end this. Don't get me started on processors and networks, but we've typically used a single processor with whom we started. And the challenge that we face is, number one, as we've grown and the scale at which we operate and the real-time nature of our business, in which we need to manage that customer experience to such a great extent where every individual who's taking a ride has multiple options. And at that point, if there are any delays or issues as part of that experience, they can go somewhere else. And we've lost that ride as well as that customer at that point. So a lot of the challenges has been the legacy nature of the existing payment network and rails. And we work with some processors. They cater to a certain size of companies, but they're not able to go beyond that in terms of scale. But the larger ones who have the scale don't have the speed and efficiency at which we need to operate. So those are at a macro level. At a more detailed level, we struggle because across multiple aspects. We treat it as a card-not-present business. And a simple example is if you take chargebacks. When we represent chargebacks, one of the requirements is you provide an address. We don't have an address. We don't need to collect an address. We know where you picked up the ride, but that's it. So how do you handle that situation? And so just applying a legacy consideration to our business doesn't work. And this is something that we want to work with the industry to try and change. It's not easy. Obviously, legacy means that there's a lot of people using it in a certain way. But those are some of the challenges that we face.
Yeah, so for the ACH, we have a team here that actually actively built the relationship with the banks. So we don't have that much issue for the big national banks because we do a lot of volume with them and we have a relationship with them and we have contacts to find the issue. But one of our big issue is for example, the smaller banks like credit unions, for example, where it's challenging.
I have two questions for this lady. I forgot her name, and also for Nan. So for Nan is that you mentioned that in your slides that you're cloning the production data. So I want to know if you can talk about some details how you use that data. I know it's a big topic. Maybe you can talk about one or two cases which cloning the production data helped your testing and the quality. And for this lady, is that you talk about the outlier detection to detect the incorrect payout. If you can give me a couple examples, like what motivates this outlier detection and what kind of incidents is detected? Can you give me an example? To give some background, because I worked for Google Payments, we had a huge double payout, probably more than some companies' revenue. And that also inspired us to build some kind of detection. But I want to know more experience and use case from Lyft. And I can also share it offline.
Thanks.
Hello. So one example where we had to use the production data that has been cloned into the test environment is when we want to stress test like our renewal process. When we, in reality, in the real production, when we do renewal, we have like over 6 million or 7 million renewals a day. But in test environment, if we don't clone that data, there's like only 100,000 customers there. So we actually, for the many years, we had to clone it. But now that we stopped cloning the data, we actually go through that process of creating millions of data of customers in the test environment. So we actually don't do that anymore. But that's what we used to do.
So we're not actually using our outlier detection to do double payout. So for our outlier detection is mostly for our right calculating how much drivers should receive, because we have to follow a lot of rules and regulation. For example, we have to pay the driver if they go through a toll. A lot of airports have very specific fees. We have to collect different tax for different cities and jurisdiction. And then it's as the platform evolves, it's very easy to stop collecting a tax or collecting a fee. So we're mostly using our outlier detection to catch things like this.
Any other questions?
Just a general question for the panel. How are you guys thinking about localization and cross-border? And is there a preference between, trying to process transactions locally versus, continuing to be cross-border, especially with, some processors being able to support localization versus others not being able to?
I think we'll let Airbnb answer this one.
That's a very good question. So because Airbnb did deal with this a lot, so what we did that we usually separate out the pay in and pay out. So because usually the guests and the hosts are in different country, and Airbnb might have a entity in both countries. So usually we do the pay. The user will pay into the entity in that country, and internally there is a treasury team that manages the funds in each country, and then they decide how and when to move the funds. And at the destination country, we will pay out to the host using the Airbnb entities, the total account. And usually, the paying is much easier because that's what a lot of the payment processors do. They can, like if you are hooked up with the Visa, you can already support a lot of countries. But the payout is very tricky. Every country might have a different payout, like a payment method, and they have different regulations for the payout. So we actually, a lot of the processors we integrate are for the payout. And one interesting scenario in Cuba, we have a payout processor that is paid out using bicycles and cash.
So question about kind of troubleshooting production issues. So there was example, like it was mentioned, like you do synchronization between production data and whatever, like non-production environment for troubleshooting. And when he was doing like once a week, it was not enough. So I'm just trying to understand what kind of, how different companies solve this problem. Like, do you do synchronization on a regular basis, or like maybe you can share like your experience like in troubleshooting production issues and synchronizing production data with non-production environment for troubleshooting?
I guess that's for me. Sometimes when you have production problems, of course, we have dashboards to figure out like anomalies, and they're very good for visualizing and finding anomalies. And then you have alerts to let you know when there are problems. But when you dig down into a specific instance, then you have a customer and you trace through the logs, and hopefully you can find the stack trace and then try to replicate that problem in the test environment. But because of the way we used to do it, we clone data only once a week. So then that data isn't, that problematic customer isn't in the test environment yet. So that's why we improved on that and moved away from cloning, and now we're creating data, and we can create data not yet in every abnormal state, but we are starting to create data in semi-abnormal state, and hopefully one day we can create data in almost any state, that even if it doesn't make sense.
So pretty much we do not try to rely on production data for troubleshooting. That's the idea.
For finding problems, we rely on the dashboards and alerts. And then digging into like specific customers, if it doesn't reach a threshold, like on our alerts or our dashboards, then we need to look into that customer and the stack trace and the logs and the Chronos events specifically. Say that again, sorry.
Yeah.
No, not yet.
Byron will be available after this for more detailed discussions. Should get him a bottle of wine and he'll talk more. We'll take two more questions.
So the question is for Gia, Airbnb. You did mention that you do smart processing for the processors, for the payment processors. Can you elaborate on more, like how do you do that? Like how do you know which payment processors will be more successful? How do you do that?
Yeah, I think there are a few. So originally, the smart processing is more for the failover when the processor is down. But after that, because we have a lot of the historic payment data, so we use that to train machine learning model, and then based on that to dynamically decide what is the best processor for that payment method.
Cool. We'll just take one last question.
Hey, this is Jacob from Visa. Quick question for all three of you. You're using multiple processors across different countries, right, et cetera. How do you actually reconcile with settlement and chargebacks? Do you have any issues with that, challenges with optimizing reconciliations, payment reconciliation?
I think CT, do you want to take this?
Not really. So I think it's
due to our financial analysts actually do the reconciliations. So as for infrastructure, we don't really know much about it at this point. I don't know if you guys know about it.
We're only in the, we don't have multiple processors whom we use. We use a single processor. But in terms of the data, in terms of chargeback reconciliation, we follow the standard process. There's nothing different that we do. We get the files from the processors, and our teams, though, the unique thing that we do is we match it to the ride that happened, and so that's the piece that we need to reconcile it to, and today we're able to do that in a pretty simple manner, at least for chargebacks. But probably Airbnb has a more complex set of situations that they deal with.
Yeah. So first, for the reconciliation, the recon we get the file from each processor. So because we use that payment code to link it back to the original payment. So usually we don't have a problem of crossing to each other payment. And for the chargeback, we have two systems with both online and offline. There's one specific service that will consume the chargeback data from different processors, and it will go through the same the internal payment service to find to create a new record for that chargeback payment, and then also find the original payment, and then it will emit an event which will trigger other systems to get the event to the online system to link back to the original product, so we know what's the context for the chargeback and whether we fight that or we assume the cost. And also, it will also go to the risk pipeline to immediately identify that user and mark that as risky, and also for the offline system to learning the behavior for that thing.
I can talk more a bit about how we do reconciliation in Lyft. So we do multi-levels of reconciliation. So we do on a transaction level. So all our transactions should match up with our third-party processors. So that's the main way we do reconciliation. We also do on a higher level recon where we match whether our processors will say that we have X amount coming in for a certain date. So we also try to match up on a higher level on a numbers basis. For chargeback, we basically get it from the offline files, and then we process them and ingest into our system. And then we work with our fraud team to decide whether we need to challenge all these chargebacks.
So basically, I think it's very similar. Short answer is reconciliation is done in the back end through a lot of files. And how we reconcile, we have two teams. One is the engineering team, and the other is the finance team. And so each transaction has a reference ID. And then so the back end, the finance team will know every reference ID, and we will be able to correlate that with the customer transaction that we renewed on that month. And sometimes we do a check, and at the end of every month, the finance team will say, hey, the numbers are off or the numbers are in line, and then we will try to figure out what the problem. And we repeat that process at every quarter too.
Cool. Thank you so much to our amazing speakers. Once again, a big round of applause to all of them. I want to thank all of you for coming in and staying so late. It's 9 p.m. and I know you have so many other things to do, and thank you so much for coming in and attending this session. We're really grateful for your presence. On your way back, please take a Lyft, watch Netflix, and go stay in Airbnb for the weekend. Have fun, guys. Thank you so much.
Ritual unions got me in trouble.